Okay, good afternoon. So today we will start unit number 7. Please write down unit number 7, shear stresses in beams. Shear stresses in beams. Shear stresses in beams. Okay, screen is visible? Yes? Okay, so first we will write syllabus and then we will cover point to point. Okay, so please write down syllabus of this unit number 7. Distribution of distribution of distribution of distribution of shear stresses in beams, distribution of shear stresses in beams, shear stresses in beams of of various commonly of various commonly used sections, various commonly used sections, various commonly used sections, such as rectangular, triangular, circular, T and I sections. T and I sections. Okay, so this is the syllabus. Here we have to focus distribution of shear stresses. So how stresses will be distributed in various sections. So sections likewise rectangular sections, triangular sections, circular, T and I sections. Okay, so already we have completed unit number 5 and unit number 5 is, what is our unit number 5? Shear force and bending moment. Okay, shear force and bending moment. So the unit number 6 and unit number 7, these two units are depend on this unit number 5. So this unit number 6 is related to bending stresses and unit number 7 is related to shear stresses. Unit number 7 is related to shear stresses and 6 is related to bending stresses in beam. So unit number 6 is depend on this half part of this unit number 5 and unit number 7 is half part of this unit number 5. So if unit number 5 is clear, then this unit number 6 and 7, not much worry to about this unit number 6 and 7. So please clear concepts regarding the shear force and bending moment diagram, because of on this unit 2 units are depends. So in half portion shear force, unit number 7 is depend, that is shear stresses in beam, and half portion bending moment, so bending stresses in beam. Okay, so already we have discussed bending stresses in beam. So anyone please draw here bending stress distribution diagram. कशी हो bending stress distribution diagram कोण draw करू शकेल? Suppose we have taken rectangular section. For this bending stress distribution diagram, many of times we have drawn. That's why I am asking. I will give one hint to you. Suppose this is neutral axis. Suppose this is neutral axis. At least now you tell me how we will draw bending stress distribution diagram. Many times we have drawn. Okay, before starting this unit, the previous example, in that also we have drawn. That homework example. Yes, those students are attending online. Please draw here. At least you try to draw. कशी असते, कुठल्या शेप मध्ये असते? चुकलं तर काही शिक्षा नाहीये. कशी असते ते तर सांगा प्लीज. काय समजले तुम्हाला त्या युनिट मधून? तर ते डिस्ट्रीब्युशन डायग्रामचे जाऊ द्यात. बेंडिंग स्ट्रेस हा मॅक्सिमम कुठे असतो आणि झिरो कुठे असतो? झिरो कुठला आहे हा? काही हे जे ड्रॉ केले ह्याला काय म्हणतात? न्यूट्रल ऍक्सिस. ओके, सो बेंडिंग स्ट्रेस इज झिरो ऍट न्यूट्रल ऍक्सिस. ओके, and maximum at extreme fiber of B, म्हणजे जिथं त्याची एज आहे तिथपर्यंत मॅक्सिमम असतो. सो बेंडिंग स्ट्रेस इज झिरो ऍट न्यूट्रल ऍक्सिस and maximum at extreme fiber. So here 0 and maximum is here. Now you draw. ठीक है. So stress distribution diagram for bending stress distribution diagram is likewise for this rectangular section. So you observe here bending stress is 0 at neutral axis and bending stress is maximum at extreme fiber. Okay, so one MCQ will be there. Bending stress is 0 at, and option is given likewise top extreme fiber, bottom extreme fiber, neutral axis, and all of the above. So bending stress is 0 at neutral axis. Another MCQ, maximum bending stress occurs at neutral axis, extreme fiber, then none of the above, all of the above. Likewise, options will be given. So you have to remember maximum stress at extreme fiber and 0 at neutral axis. Okay, 0 at neutral axis. So we have drawn here inclined line. Why we have drawn here inclined line? स्ट्रेट इन्क्लाइन लाईनच का ड्रॉ केली मी? पॅराबोलिक किंवा इरेग्युलर शेप का ड्रॉ केला नाही? कशासाठी ड्रॉ केली सांगा बरं? This distance is y max. Okay, this distance is y max. Again, this distance is y max. Or flexure formula is with you, m by I, which is equal to sigma by y, which is equal to E upon R. So from this, you tell me why we have drawn this inclined straight line. Already we have discussed how to draw bending moment and shear force diagram for point load, uniformly distributed load. When we will draw curvature, when we will draw straight line, when we will draw cubic polynomial. So I'm giving hint. So by using these hints, you tell me why we have drawn this line as an inclined straight line. Point load नाही, मी इथे लोडच दिला नाही ना कुठलाही तो, तरी पण मी ड्रॉ केली. You observe here y raised to power is 1. Here y raised to power is 1. That's why the stress distribution, bending stress distribution diagram is inclined straight line. Please remember this thing also. Stress distribution diagram is inclined straight line because of y raised to power is 1. That's why this line is inclined line. And from this figure, you have to remember bending stress is 0 at neutral axis and maximum at extreme fiber. So that much point we have discussed in unit number 6. Now we will move towards our unit number 7. So already you know that. Okay, already you know that beam is in pure bending. Okay, beam is in pure bending. So what is meant by pure bending? Pure bending means in that beam only bending moment is present. In unit number 6, we written one assumption: beam is in pure bending. Beam is in a state of pure bending. In a state of pure bending. So pure bending means that is only bending moment is present. Bending moment is present and shear force is 0. So this is already we have discussed in unit number 6. But in reality, suppose we have taken this is beam. and we have applied W intensity of load. When we will apply this load, at that time, how many stresses will be generated in that beam? Two types of stresses will be generated. First one is the shear force or shear stress, and second one is the bending moment. So this assumption is only theoretical point of view, but in reality, whenever we will apply load on a particular beam, at that time two stresses will be generated. First one is the shear and second one is the bending. Second one is the bending. So this thing also you remember. After that, in these cases, okay, so here shear stress and bending stresses, both stresses are developed. So in these cases, both normal and shear stresses induced in the beam. म्हणजे काय होतं की ह्या बीम वरती जर आपण लोड अप्लाय केला तर रियालिटी मध्ये इथं दोन स्ट्रेसेस जनरेट होत आहेत, shear stress as well as bending stress. Okay, so these stresses will be calculated by using which formula? Fletcher formula. Bending stresses or normal stresses will be calculated by using Fletcher formula. So before starting of this unit number 7, you have to remember first point. Already we know that when beam is in a state of pure bending, that is in that beam only bending moment is present, shear force is 0. However, but in reality, beam carries two stresses. First one is the shear stress and second one is the bending stress. And these bending or normal stresses are calculated by using this Fletcher formula, and these shear stresses will be calculated by shear stress formula. That much, or this is the basic. Now we will move towards the shear stress formula. Okay, because of here distribution of shear stresses is given, but before that we have to see how we will calculate shear stresses. So shear stress is tau. So tau, which is equal to, what is the equation? Already we have discussed a Fletcher equation, m by I, which is equal to sigma by y upon E upon, which is equal to E upon R. So by using this equation we will calculate bending stresses, but we have to calculate these shear stresses. So for this, first we will derive this equation, and after that we will see the distribution of shear stresses in various beams. So please write down next point. Shear stress equation. Shear stress equation. Okay, first we will derive shear stress equation. So shear stress is denoted by using tau letter. Tau. So first we will write one sentence. You also write let at any section. So we will take here two sections. Let at any section AB. So we will first take AB section. The bending moment and shear force are M and S. Suppose we have taken AB section. So in that section, two types of stresses will be generated, bending stress as well as shear force. So bending moment is denoted by using M and shear force is denoted by using S, respectively. Solpaviram. Let another section be CD. Let another section CD at a distance dx. At a distance dx. So after that we have considered another section at a distance dx. Okay, from AB. The bending moment and shear force are Okay. Now, for AB, bending moment and shear force are M and S. For CD section, we have to calculate bending moment and shear force. So for this CD section, bending moment and shear force are M plus DM, M plus DM, and S plus DS, S plus DS respectively, S plus DS respectively. म्हणजे काय केलेलं आहे आपण सपोज AB सेक्शन कन्सिडर केलेलं आहे आणि त्याच्यापासून समथिंग डिस्टन्स वरती आपण CD सेक्शन घेतलेलं. मग ह्या AB सेक्शन मध्ये बेंडिंग मोमेंट M and shear force S, and here we have taken distance, so bending moment is M plus DM and shear force is S plus DS. Okay, now we will derive equation. So this is the first assumption. Okay. So already you know that bending stress equation, sigma which is equal to M by I into Y, M by I into Y. Okay, now we will write for this second part, second CD portion. So sigma plus D sigma, which is equal to sigma plus D sigma, which is equal to M plus DM divided by I into Y, divided by I into Y. Okay, so that much bending stress will be generated in AB portion and that much bending stress will be generated in CD portion. After that, we will convert this stress into force. Okay, we will convert stress into force. So how we will convert stress into force? कसं convert करू शकतो? Already you know that. Okay, I will write here sigma, which is equal to force upon area. When you have to find out force, at that time force which is equal to sigma into area. So we will multiply by del A to left side as well as right side. Okay, so sigma plus del sigma, which is into del A, which is equal to M plus dm divided by I into y as it is, and here we will multiply by del A. Okay, why we have multiplied by del A? Because we want this force. So force is nothing but stress into area. After that, we will take integration. So this is for small portion. We will take for integration. So ds, which is equal to M plus dm divided by I. Okay, this is as it is, M plus dm divided by I minus M by I. Okay, so here we have equated this equation and this equation, both these equations. So M by I into Y, which is equal to M. So this M by I we have shifted to this side, so minus M by I, and we will take this y as a common because of here y and here also y is there. So we will take y into del A, म्हणजे आपण इथे काय केलेलं आहे, तर ही जी काही राईट साइड आहे इक्वेशन, सपोज वी विल कन्सिडर दिस वन अँड दिस टू, सर ह्याची राईट साइड इक्वेट केलेली आहे. मग ते इक्वेट कसं केलं बघा, इथे तुम्हाला लिहून दाखवते मी, m by I into y which is equal to m plus del m divided by I into y into del A. Okay, so we have shifted this M by I to this side, that's why M by I, and this y and y we have taken common, and this is the del A. Okay, that likewise we have written here equation. So after solving, what you get, ds which is equal to, solve केल्यानंतर काय मिळणार आहे बघा आपल्याला, ds which is equal to del m divided by I into y dA. बघा इथं काय आहे, m plus del m minus y, so this plus y and minus y gets cancelled, so del m upon I into y into del A, that much remaining. So del S which is equal to this is. Now we will calculate total unbalanced force. So this is related to that particular section. So we will calculate total unbalanced force. So total unbalanced force which is equal to total unbalanced force, total unbalanced force, which is equal to summation of del m divided by I into y dA. So from this we will take this del m upon I as a common, so which is equal to del m upon I into summation of y del a. So after taking summation del m upon I, which is equal to y into del a, nothing but area into y bar. Area into y bar. So this is the area related to small portion, and we are taking here integration or summation. That means from bottom to top. So del a replaced by a and y replaced by y bar. So total unbalanced force, which is equal to del m divided by I into a y bar. This is for whole section. After that, we will calculate shear stress. After that, we will calculate shear stress. So shear stress, which is equal to tau, which is equal to unbalanced force divided by area, shear area. Unbalanced force divided by shear area. So unbalanced force already we have calculated. This is del m divided by I into ay bar. Now this area is divided. So area is nothing but width of that section into depth. Okay. So already we have assumed this distance del x into width. So area is at denominator dx into b, and this is 1. So when we will shift at that time, 1 divided by dx into b. So this is the area. So from this we will calculate shear stress. So tau, which is equal to dm into ay bar divided by I into 1 divided by dx into b. So now we will take dm by dx. dm divided by dx. What is remaining? Ay bar divided by I into b. And already we have discussed dm by dx in unit number 5. Interrelation between intensity of load, shear force and bending moment. When we will take derivative of movement, at that time you will get shear force S into ay bar divided by IB. Got it? Already we have discussed in unit number 5, interrelation between intensity of loading, shear force and bending moment. When we will take derivative of movement, at that time you will get this shear force. So S A y bar divided by IB. Therefore, shear stress, which is equal to SA y bar divided by IB. This is the equation for finding out shear stress. If this derivation is not understand or difficulty in remembering, don't worry, you just remember this equation. Tau, which is equal to SA y bar divided by IB. But as an engineer, you know that how this derivation come. That's why I have taken here. Okay. So now we will discuss term of this shear stress terms in shear stress formula. So once again I will write here tau, which is equal to SA y bar divided by IB. So this tau is already, you know, that shear stress. Tau is nothing but shear stress. Tau is nothing but shear stress. After that, this S means shear force. S is the shear force. Then this I is the moment of inertia. Then this B is the width. But this width is related to, suppose this is I section. Okay, this is I section. And we have to find out here stress distribution at this section. So we will consider width this. Suppose we have to find out the stress at neutral axis. Then this is will come as a width. Width कशावर depend है? At which point you are going to find out shear stress. So on that point, this width will be depend. So width means B means not only width, but at which point you are finding shear stress. Accordingly, this width will be changed. And last thing is remaining, that is area into y bar. Okay, so for this I will give a y bar. So this is the area with centroidal axis. Okay, so how you will calculate? Suppose this is section. Okay, suppose this is section. So whenever we will take this is as a neutral axis. Okay, this we will consider as a neutral axis, and I have to find out shear stress at this EF. Shear stress at this EF. Suppose this is my EF strip. Okay, and we have to find out stress at F. So width is nothing but this. Suppose this is A distance and this is X distance. So we will consider B as a X. We are finding out shear stress at this location. Now we have to concentrate on this A into Y bar. Okay, so area is A into X. A into X. म्हणजे काय करायचं आपल्याला, जिथे एरिया फाइंड आउट करायचा आहे त्या पर्टिक्युलर पोर्शनचा एरिया. सो दिस डिस्टन्स इज ए अँड दिस डिस्टन्स इज एक्स. सो ए इंटू एक्स. नाउ वी हैव टू टेक y bar. So y bar means distance from neutral axis to centroid of that particular section. Okay, distance from neutral axis to centroid from that centroid for that particular section. So this is a y bar. So likewise you have to take y bar. लक्षात आले y bar कसा घ्यायचा आणि एरिया. जर समजा तुमचा तोच I सेक्शन असेल, I section. Okay, suppose this is neutral axis of this I section. At that time y bar means from this neutral axis to centroid of this particular wave, this is called as y bar. And area is depend on at which point you are finding stress. Suppose you are finding at neutral axis. At that time you have to convert this area, consider this area as well as this area. But if you are finding only for this, so at that time area for this only straight. So area and y bar is depend on at which point you are finding out stress. So accordingly this area and y bar will be changed. Okay, if we will solve 1-2 numericals, at that time you will get idea. But time being you remember tau, which is equal to SA y bar divided by IB. Okay, so please take screenshots. So we will find out shear stress for rectangular and circular section, and then we will solve numericals. Take screenshots. Okay, now write down next point. Shear stress distribution in various sections. Shear stress distribution, shear stress distribution in various sections. So first we will consider rectangular section. Rectangular section. Okay. So for this, first I will draw figure. So rectangular section already you know that. Likewise. So width for this rectangular section is B. First we will mark neutral axis. Suppose this is neutral axis. Then we will locate at which point we have to find out shear stress. Suppose we have to find out shear stress at this strip. We will mark as a EF. Suppose this is A, B, this is C, and this is D, and we are finding out shear stress at EF. We are finding out shear stress at EF. So from this neutral axis to EF distance, this is a only Y. Okay, only Y distance. At which point we are going to find out shear stress. This is our neutral axis. This is our neutral axis. So this is the width of section. This is the width of section, and this is the total depth of section. This is total depth of section, total D. So when we will divide into two parts, this will come as a D by 2. This will come as a D by 2. Now, please concentrate here. After that, you take screenshots. Because of writing is not important, concept clearance is very important. So shear stress, what is our equation for finding out shear stress? Tau, which is equal to SA y bar divided by IB. Tau, which is equal to SA y bar divided by IB. S nothing but shear force. This is depend on type of loading and amount of load. I is depend on moment of inertia. B is depend on where you have to find out shear stress. And this A y bar is most important. If A y bar is not clear, then you are unable to find out shear stress in that particular member. Okay, so first we will find out A y bar. So A y bar, which is equal to. Now we have to find out the shear stress of this strip. Shear stress of this strip. So area for this strip is B into D. Now I have to calculate D. How I will calculate D? ह्या स्ट्रीप साठीचं हे डिस्टन्स मला फाइंड आउट करायचंय. इथं पासून ही आपली जी स्ट्रीप आहे इथं पर्यंत
D by 2 minus y.
नाही ना, D by 4 plus y घ्यायचं म्हटलं तर मी कुठं असं म्हटलंय की ते D by 2 च्या हाफला परत आहे म्हणून. तसं दिलेलंच नाही आपल्याला. तर कोण ऑनलाईन कोणीतरी सांगितलेलं आहे, बरोबर आहे ते D by 2 minus y. So this distance will be बघा. टॉप पासून ते इथपर्यंत D by 2 आहे. त्याच्यातून जर हे y डिस्टन्स मायनस केले तर आपल्याला हे डिस्टन्स मिळते. जे डेप्थ फॉर दॅट पर्टिक्युलर स्ट्रीप इज D by 2 minus y and width is B. So area is B into D by 2 minus y. So this area is over. Now we have to focus on this y bar. कोण सांगेल y bar काय असेल? बघा y bar डिस्टन्स काय घ्यायचे आता मी परत इकडे मार्क करते. ह्या सेंटर पासून ते ह्या न्यूट्रल ऍक्सिस पर्यंत डिस्टन्स घ्यायचा. जरा थोडं तुमचं डोकं लावून सांगा बरं काय घेऊ शकतो आपण.
Y plus D by 2 minus y upon 2.
Y plus
D by 2 minus y total divide by 2.
थोडं चुकते.
ते वरच्या डेप्थचा हाफ घ्यायचा ना, D by 2 minus y divide by 2 plus y.
हे बघा इकडे लक्ष द्या. आता आपल्याला y बार मी इथे कॅल्क्युलेट करून दाखवते. y बार विच इज इक्वल टू फर्स्ट हे आपलं D by 2 आहे. हे डिस्टन्स किती आहे तुमचं D by 2 मायनस ओके D by 2 मायनस हाफ ऑफ दिस डिस्टन्स. This distance is D by 2 minus y. D by 2 minus y. Okay. So y bar which is equal to here D by 2 is there na. Okay. So we will multiply by here. So D by 2 minus D by 4 minus plus y by 2. We will make same denominator.
Plus पाहिजे. D by 2 plus half y bar.
प्लसच घेतलंय की आपण y by 2. कुठलं म्हणताय?
वरती D by 2 plus half.
D by 2. हा First I will explain, then you ask question. Y bar which is equal to d by 2 minus 1/2 d by 2 minus y. Okay, so for we will multiply by this d by 4 plus y by 2. So here we will multiply by 2. So we'll make same denominator. So y bar which is equal to 2d minus d divided by 4 plus y by 2 plus y by 2. So y bar which is equal to d by 4 plus y by 2. D by 4 plus y by 2. Suppose I will take 1 by 2 common. What is remaining? D by 2 plus y. So this is the y bar distance from this to this. किती असणार आहे तुमचं 1/2 d by 2 plus y. So this is the y bar distance. Now we will calculate a y bar. We will calculate a y bar. Okay. How we will calculate? We will multiply by this. So a y bar which is equal to b divided by 2. Okay, b divided by 2 in bracket. Okay, this d into d square. Okay, this d into d square. This 1 by 2 we have taken here common. Okay, 1 by 2 divided by this 2 into 2, 4. After that, this minus y into plus y. Minus y square. Okay, minus y square. Up to this point, anybody having doubt? Now we will write tau which is equal to, what is our equation? Tau which is equal to SA y bar divided by IB. So tau which is equal to SA y bar divided by IB. So tau which is equal to S we will write as it is, IB we will write as it is, and we will write value of this AY bar. So value of AY bar is b by 2 d square by 4 minus y square. Okay, minus y square. After that we will write the value of this I, moment of inertia. Okay, so tau which is equal to S divided by moment of inertia for rectangular section is BD cube. Here divided by 12. So when we will shift this, it will at numerator. So 12S divided by BD cube into width of that section is already width. So B, and here B by 2 in bracket d square by 4 minus y square. आता थोडं लक्ष द्या, इथं काय काय कॅन्सल होऊ शकते सांगा बरं. So first we will 2, 2, 6. Then this b and this b gets cancelled. Yes. नाही पण d square by 4 आणि minus y square ते कॉमन मध्ये आहे ना. So tau which is equal to 6s divided by bd cube d square divided by 4 minus y square. So this is the shear stress for this rectangular section. Now we will put the value of y. We will put y which is equal to plus d by 2. कधी हे प्लस डी बाय 2 पुट करतोय म्हणजे कुठल्या इथे फाइंड आउट करतोय आपण, या टॉपला फाइंड आउट करतोय बघा. जर मी y which is equal to d by 2 व्हॅल्यू पुट करत असेल तर न्यूट्रल ऍक्सिस पासून टॉपला शियर स्ट्रेस फाइंड आउट करते. तर त्यावेळी काय येणार आहे तुमचं इक्वेशन? वी विल राइट हियर. ओके, सो आवर बेसिक इक्वेशन इज 6s divided by bd cube d raised to d square by 4 minus y square. So here we have to put value of y square. So tau which is equal to 6s divided by bd cube as it is into in bracket d square by 4 as it is, this minus sign is as it is, and we are putting d by 2. So d square by 4. So when we will put d square by 4, automatic this term will get cancelled. So tau which is equal to 0. So shear stress at top, which is equal to 0. After that, we will put y, which is equal to minus d by 2. Y, which is equal to minus d by 2. So tau, which is equal to 6x divided by bd cube in bracket d square by 4 minus as it is. And the value of this y square is minus d by 2 square. So जर d ची व्हॅल्यू इथं मायनस आहे पण स्क्वेअर केला तर ती काय होणार आहे प्लसच होणार आहे. सो d square by 4. Again this term will get cancelled. So tau, which is equal to 0. So here we will write, if we will put d by 2, at that time shear stress at top, shear stress at top, shear stress at top. And then we will put y, which is equal to minus d by 2. That means shear stress at bottom, shear stress at bottom. And already we have calculated for neutral axis, tau, which is equal to sigma x divided sigma s by bd cube d raised to d square by 4 minus y square. So shear stress at top and shear stress at bottom is 0 and shear stress at neutral axis is maximum. Now you observe here the y raised to power is 2. Highest power of y is 2. That means it indicates the distribution of shear stress diagram is parabolic. I will draw here shear stress distribution diagram. We will extend these lines. So from this top to bottom, this is likewise. And here y raised to power is 2. That's why the shear stress distribution diagram is likewise. So please remember, here shear stress is 0. Here also shear stress is 0. And at neutral axis shear stress is maximum. So stress distribution diagram 0 at top, whereas bending moment or bending stress is maximum at top. बघा हे दोघं एकमेकांच्या अपोजिट आहेत. बेंडिंगचं कसं होतं आपलं या फॉर्म मध्ये, म्हणजे न्यूट्रल ऍक्सिसला 0 होतो तिथं शियर स्ट्रेस मॅक्सिमम असतो आणि जिथं शियर स्ट्रेस 0 असतो तिथं बेंडिंग मोमेंट मॅक्सिमम असते. ओके, so this is the tau max. From this we will write tau, which is equal to, okay, after that we will put y, which is equal to 0. We will put y, which is equal to 0. If I will put y, which is equal to the 0, then I will get y, which is equal to 0. So tau, which is equal to 6s divided by bd cube in bracket d square by 4 minus the value of y square is 0. So here 2 1s are 2, 2 3s are 6. So tau, which is equal to 3s divided by 2 bd cube divided by 2 bd cube. But here d square and d square gets cancelled. So what is remaining? 2 divided by bd. So tau, which is equal to 3s divided by 2 bd. So when we will put y, which is equal to 0, that means we are finding out shear stress at neutral axis. Shear stress at neutral axis. So tau, which is equal to 3s divided by 2 bd. So shear stress at neutral axis 3s divided by bd. Now this s divided by bd, s means already you know that shear force, divided by bd, that is area. So force upon area is nothing but the stress. Okay, so for this I will write here, so tau average, which is equal to 3 by 2 into 3 by 2 into s divided by bd. S divided by bd. Tau average, not tau average, tau maximum. So maximum stress you will get at neutral axis. If we will put value of y is 0, at that time shear stress is 3s divided by 2 BD. So tau max, which is equal to 3 by 2 into s divided by BD. And s divided by BD is nothing but the stress. So maximum stress, which is equal to 3 by 2 into tau average. So one MCQ will be here. Rectangular section, maximum shear stress for rectangular section in terms of tau average, which is equal to 1.5 tau average. तर हे डेरिवेशन नाही लक्षात आलं, काही लक्ष देऊ नका. फक्त रेक्टँग्युलर सेक्शनचा शियर स्ट्रेस कसा असतो, मॅक्सिमम स्ट्रेस विच इज इक्वल टू 3/2 टाउ ॲव्हरेज, दॅट इज 1.5 टाउ ॲव्हरेज. हा 1.5 फॅक्टर तेवढा लक्षात ठेवा, कारण मॅक्सिमम हे पण दिलेलं असतं आणि ॲव्हरेज पण दिलेलं असतं. फक्त तुम्हाला काय लक्षात ठेवायचंय, 1.5. सो फॉर रेक्टँग्युलर सेक्शन मॅक्सिमम स्ट्रेस विच इज इक्वल टू 1.5 टाइम्स ॲव्हरेज स्ट्रेस. ओके, पण ते कसं आलं त्याच्यासाठी आपण हे डेरिवेशन घेतलेलं आहे. तर या डेरिवेशन मधून 3 गोष्टी लक्षात ठेवा. फर्स्ट थिंग इज shear stress distribution diagram is parabolic. Why this parabolic? Because of y highest power of y is 2. After that, second thing is shear stress is at top and bottom fiber 0 and maximum at neutral axis. And third one thing is maximum shear stress, which is equal to 1.5 times average stress. Okay, so that much things you have to remember. Please take screenshots, because of this derivation is not important, but that 3 points are very important. So maximum MCQ will be asked on unit number 5, 6, 7, because of more MCQ will be generated on these units. So please remember. Then we will discuss shear stress distribution for circular section. Shear stress distribution for circular section. Circular section. Circular section. इथं पण आपल्याला तेच फाइंड आउट करायचंय. टाउ मॅक्स विच इज इक्वल टू हाऊ मच टाइम ऑफ टाउ ॲव्हरेज. ठीक आहे, त्याचं डेरिवेशन घेऊया का डायरेक्ट फॉर्म्युला देऊया? ऍज पर युअर कन्व्हिनियन्स. तुम्ही घ्या म्हणत असाल तर घेऊया, जर म्हणत असाल फॉर्म्युला तर फॉर्म्युला. काय करायचं सांगा. बघा, आता त्याचं एक थोडं जनरल मी तुम्हाला सांगते की त्याच्यात काय करायचं डिटेल न जाता. तर हा सर्क्युलर सेक्शन. ओके, सो दिस इज द सर्क्युलर सेक्शन. इन दॅट दिस इज न्यूट्रल ऍक्सिस. ओके, neutral axis, and here also we have to locate at which point you have to find out shear stress. Same procedure here also you have to find out. So suppose we are going to find out shear stress at this portion. We will call as a EF. We will call as a EF. After that, suppose this is our centroid. Okay, so from this neutral axis to this distance is y. Already you know that this distance is y. So we will consider this as a right angle triangle. This as a right angle triangle, and here 90-degree angle is there, and this represents as a radius r. Okay, this is our neutral axis. This is our neutral axis, and here we have to find out the width of EF. First, you have to find out width of EF. Width of EF. So how you will find out the width of EF? कशी find out करणार? First we will divide this EF into 2 part. बरोबर आहे. हे टोटल EF आहे ते 2 पार्ट मध्ये डिवाइड होते बघा तुमच्या. सपोज विल मार्क ऍज अ N point. Suppose this is N. So N, suppose we will mark this as a O. NOEF is the right angle triangle. Okay, so here we will apply Pythagoras theorem, and by using this Pythagoras theorem we will find out this NF. Once you got this NF, then you multiply by 2, so automatically you will get this EF. So width of EF, which is equal to 2 square root of आर स्क्वेअर मायनस वाय स्क्वेअर. बघा आता ते कसं आहे ते सांगते थोडं. तर हा आपल्याला ट्रायंगल कन्सिडर केलेला आहे ONF. इथे आपल्याला पायथागोरस थेरम अप्लाय करायचा आहे. तो पायथागोरस थेरम इज आर स्क्वेअर विच इज इक्वल टू पाय स्क्वेअर plus nf square plus nf square. So now I will write in terms of nf square. So nf square which is equal to r square minus y square. So nf which is equal to square root of r square minus y square. Got it? Now this is, and I have taken these two because of under root of r square minus y square is for this half, and for this half again r square minus y square. So 2 times r square minus y square. So this is the width of EF. After that same procedure you have to follow here. First you have to find out area of y bar. Sorry, a into y bar. So for this we will take integration y to r. That is from this y, okay, and up to this radius y to r. So 2 times area, okay, 2 times r square minus y square into y dy, okay, into y dy. Then we will consider, let us consider 2 square root of r square y square which is equal to u. आपण काय करूया, 2 square root of r square minus y square च्या ठिकाणी u पुट करूया, म्हणजे आपल्याला सॉल्व्ह करायला थोडं सोपं जाईल. जर लक्षात येत नसेल तर लोड घेऊ नका, फक्त एक कसं आहे ते त्याच्यासाठी चाललेलं आहे ते. ठीक आहे, we will put here 2 square root of r square minus y square which is equal to u. इथं पुट करूया. ठीक आहे, so 4 square root of r square minus y square which is equal to 2u, 2 times u. Now we will take derivative. We will take derivative. Okay, we will take derivative. So our equation is minus 4 into 2y dy. Okay, we have to take derivative for this. Okay, so 2 square root of r square, instead of this we will write for this here only r square minus y square is 2, and here suppose we will write 2, so at that time 2u. So derivative of this r square in terms of this y you have to take. So derivative is minus 4 into 2y dy which is equal to 2u du. म्हणजे इथे या इक्वेशन मध्ये इथे तुम्हाला काय करायची, व्हॅल्यू पुट करायची u ची. सो इथे काय येणार आहे तुमची 2u व्हॅल्यू असणार आहे. ओके, तर त्याचा डेरिव्हेटिव्ह घ्यायचा आहे. सो ay बार विच इज इक्वल टू, बघा हे मायनस आहे तर ते मायनस साइन काढण्यासाठी आपण काय करूया, 0 टू u पुट करण्याच्या ऐवजी u टू 0 पुट करूया. म्हणजे काय करेल, मायनस कडून प्लस कडे कन्वर्ट होणार आहे ते. मग ते काय झालं तुमचं u, दिस इज u पार्ट इनटू y bar is minus 1/4 into u du. Okay, u du. After that we will take this as a common. So ay bar which is equal to this is our original term. After that you will convert, that is 0 to u, so which is equal to 1/4 as a common. So what is remaining, u square into du. So ay bar which is equal to, okay, ay bar which is equal to the derivative of this y square is, now we are taking this here integration, y cube, so u cube divided by 3 and this 4, okay, 3 into 4, so which is equal to u cube divided by 12. So ay bar which is equal to u cube divided by 12. Remaining formula same, tau which is equal to SA y bar divided by IB. So S and IB we will take as it is, and the value of this AY bar is u cube divided by 12. Now we will put the value of this moment of inertia. Okay, so our equation is likewise tau, which is equal to S divided by I. Okay, we will write here U cube divided by 12, U cube divided by 12, and B nothing but 1 divided by U, because of width is 2r square minus y square. So here 1 by U, width is 1 by U. After that, we will put the value of this I. So tau, which is equal to tau, which is equal to, so here 1u and 1u gets cancelled. So s u square divided by 12i. Now we will put value of I. So s u square divided by 12 into the value of I is pi by 4 into r raised to 4. Pi by 4 into r raised to 4. So after solving this, tau which is equal to, म्हणजे हे आपलं वरती शिफ्ट करून सॉल्व केल्यानंतर tau which is equal to 4 divided by 3 s divided by pi r square. ओके, s डिवायडेड बाय पाय आर स्क्वेअर. इथे u ची व्हॅल्यू पुट करायची तुम्हाला नंतर. ते सॉल्व केल्यानंतर काय शिल्लक राहते, टाउ विच इज इक्वल टू 4/3 s डिवायडेड बाय पाय आर स्क्वेअर. सो दिस s डिवायडेड बाय पाय आर स्क्वेअर मीन्स tau max, which is equal to 4/3 tau average. So you have to focus on this equation only. So for circular section, tau maximum, that is maximum stress, which is equal to 4/3 times tau average. Only this equation you remember. Okay, so till now we have discussed what is the equation for finding out shear stress. So tau which is equal to SA y bar divided by IB. After that, shear stress, maximum shear stress for rectangular section is 3/2 tau average, and for circular section tau max, which is equal to 4/3 tau average. So these three equations is important for solving numericals. Okay, now we will solve numericals. Please write down first example. Examples are easy, but these derivations are difficult, but you don't concentrate on derivations, because of no any derivation will be asked in any examination for university as well as for any competitive examination. But these three equations will be asked in your university examination as well as any competitive examination as well as GATE examination. These two are the most important. याच्यावरती एक तरी 100% क्वेश्चन विचारले असतो की टाउ मॅक्स फॉर रेक्टँग्युलर और सर्क्युलर. इथे तुम्हाला लक्षात ठेवायचे फॉर रेक्टँग्युलर 1.5 or 3/2 and for circular 4/3. Now we will solve example. Please write down first example. First we will take on symmetric section. A beam of span 10 meter simply supported 10 meter simply supported at the end, simply supported at the end carries a point load of 50 kilonewton at the center. Point load of 50 kilonewton at center. 50 kilonewton at center for the I section. For the I section shown in figure below. shown in figure below. Full stop. Draw the shear stress distribution. Draw the shear stress distribution. Draw the shear stress distribution. Draw the shear stress distribution and show the value of stresses at important location, and show the value of stresses at important location, important locations. So here I section is given, and with this I section, one simply supported beam is also given. So we will draw here simply supported beam. So this is simply supported beam, and on that simply supported beam, one central point load is applied. Okay. So for this I section is given. So I will draw here section. So this symmetric section is given. Okay. So span for this simply supported beam is 10 meter. So 5 meter here and 5 meter here. And intensity of this central point load is 50 kilonewton. Intensity is 50 kilonewton. So from this, you have to find out reaction at A, that is shear force at A and shear force at B. So how you will calculate? कसं calculate कराल सांगा?
Summation of FV equal to 0 and summation of movement equal to 0.
Summation of FV which is equal to 0. So RA plus RB minus 50 which is equal to 0. So RA plus RB which is equal to 50. After that, summation movement at A which is equal to 0. So minus RB into 10 plus 50 into 5 which is equal to 0. We'll shift this R minus RB to right side. So 50 into 5 is 250 which is equal to 10 RB. So RB which is equal to 250 divided by 10. So RB which is equal to 25 kilonewton, 25, and then RA which is equal to 50 minus 25. So RA which is equal to again 25 kilonewton. Without calculating this, please remember 50 kilonewton force is there. Out of that 50, half will be carried by this A part and half will be carried by B part. So without calculation, you will get this answer. Now we will focus on this. So this is the 150 mm. After, so this is AB. No, this is AB. 150 distance. This distance is 20. Okay. This distance is again 20. This distance is 10. This distance is 10. And this distance is 250. This distance is 250. First, we will mark neutral axis. We will mark neutral axis. This section is symmetric, so we are able to mark neutral axis directly. So the distance of neutral axis, how much? किती असणार आहे हे डिस्टन्स आणि हे 250 plus 20 plus 20, that is 290. 290 divided by 2. This is 145, right? And this is also 145. So these distances are 145 and 145. So we'll mark, suppose this is A point, this is B, this is C, this is neutral axis D, after that E, F, and this one is the G. First we will calculate moment of inertia, I, which is equal to BD cube divided by 12 minus, okay, first we will consider this whole figure, and after that we will subtract these two parts. So minus 2 into, so here we will consider capital B and small b, so you will get easily understood. So I, which is equal to capital BD cube by 12 minus 2 into small BD cube by 12. तर हे कसं कॅल्क्युलेट करणार आहे? कॅपिटल B म्हणजे 150, capital D addition of this whole. So I, which is equal to 150 into 290 cube divided by 12 minus 2 into, now we have to find out this B. So 150 minus 10, 140, okay, divided by 2, so 70. 2 into 70 into this distance is 250. So 250 cube divided by 12. So you calculate and tell me I, which is equal to how much? Okay, 122.57 into 10 raised to 6 mm raised to 4. So this is the moment of inertia. Okay, shear force already we have calculated. Okay, so yes, then AY bar we will calculate at that particular point. So now we will calculate stress distribution. So first we will calculate at A and at G. So now you tell me at A and G shear stress will be 0 because of already we have derived equation. So at top and at bottom, at top and at bottom shear stress is 0. So by using this, now we will calculate shear stress distribution. Shear stress distribution. Shear stress distribution. So shear stress at A, tau A, which is equal to tau G, which is equal to 0 kilonewton. आता बघा, एक तर आपण न्यूट्रल ऍक्सिसच्या वरती कॅल्क्युलेट करायचं किंवा एक तर न्यूट्रल ऍक्सिसच्या बिलो. जर बी पॉइंटला जेवढा स्ट्रेस आहे तेवढाच तुमचा एफ पॉइंटला स्ट्रेस असणार आहे, जेवढा सी पॉइंटला स्ट्रेस आहे तेवढाच ई पॉइंटला असणार आहे, आणि डी तर पॉइंट एकच आहे. ए पॉइंटला 0 आहे, जी पॉइंटला पण 0 असणार आहे. नाउ वी विल कॅल्क्युलेट शियर स्ट्रेस ऍट बी, which is equal to shear stress at F. So shear stress tau B, which is equal to tau F. So formula is SA Y bar divided by IB. So which is equal to S. Shear force already we have calculated it. Shear force in kilonewton, so we will convert into Newton. So 25 into 10 raised to 3. Now we will take area into Y bar. Please concentrate here. We are calculating at this B point. That means we have to consider area above this B. So this figure will become. So area is 150 by 20. So area is 150 into 20. And we have to find Y bar. So Y bar is this to this distance. Okay, this to this. So this is 145 minus 10. That means Y bar. So 135. Okay, 135 divided by I. Already we have calculated moment of inertia. 122.57 into 10 raised to 6 into V. Now we are calculating at this location. So width is 150. Now you calculate and tell me shear stress at B, which is equal to shear stress at F, which is equal to how much? How much? 0.5507 Newton per mm square. So next we will calculate at C and E. So shear stress at C, which is equal to shear stress at E. Okay. So next we will calculate shear stress at C. So tau C, which is equal to tau E, which is equal to, equation is SA y bar divided by IB. So which is equal to, shear force is common for all. So 25 into 10 raised to 3 into. Now we are calculating at C point. So above C area is again same. Yes, लक्षात येते का बघा? एरिया काय आहे तुमचा? सेम आहे. So 25 into 10 raised to 3 into area is 150 into 20 into y bar. So here y bar is again same. So y bar is how much? 125. Okay, so here 125 divided by I. I is 122.57 into 10 raised to 6. 10 raised to 6 into width. Width is how much now? We are calculating at this C point. So width is 10. So here 10. You calculate and tell me tau C, which is equal to tau E, which is equal to how much? So now you got this B, how changes? So this B will be changed with respect to location. How much? 7 point Newton per mm square. After that, we will calculate at this D. So next point is shear force at D. SA y bar divided by IB. So which is equal to, shear force is 25 into 10 raised to 3. Okay. Into area. Now we are calculating at this D point. So this flange and this wave portion will be there. So first we will take area of this and y bar for this. So 150 into 20 into y bar for this particular is 135. Okay. After that we will consider this remaining half. So for this remaining half, this distance is how much? 125. Okay. So 125 into width is 10 and y bar for this particular section is 125 by 2. So that is 62.5 divided by moment of inertia is 122.57 into 10 raised to 6 into, now here width. So this D point is located at this, in this wave. So width is 10. So you calculate and tell me tau d, which is equal to how much? Yes, how much? 0 point into चुकतं काय तर आन्सर चेक करा बरं. चेक करा बरं एकदा. तेवढंच येते. ठीक आहे. बघ आता स्ट्रेस कॅल्क्युलेट केलेले बरोबर आहेत का चुकले हे कशावरून ओळखायचं? तर शिअर स्ट्रेस ऍट टॉप अँड बॉटम 0 आहे. ठीक आहे. त्यानंतर बी आणि एफ ची व्हॅल्यू काहीतरी आलेली आपली. बी आणि एफ ची 0.55 आली. त्यानंतर सी आणि ई ची व्हॅल्यू त्याच्यापेक्षा जास्त आली 7.65. आणि शिअर स्ट्रेस ऍट न्यूट्रल ऍक्सिस इज मॅक्सिमम. सो अवर व्हॅल्यू इज मॅक्सिमम. सो अवर कॅल्क्युलेशन्स इज करेक्ट. Now we will draw shear stress distribution diagram. So first we will draw given section and then we will draw shear stress distribution diagram. So this is suppose our I section. First we will locate neutral axis. Okay. So we will extend these all lines. Now we will draw shear stress distribution diagram. First we will mark all values and then we will draw. So this is our A point. This is B, C, D, E, F and G. So accordingly we will mark shear force at A and shear force at G is 0. After that shear force at B. Shear force at B is 0.55. After that shear force at C. जे त्याच लाईनला पॉइंट आहे बघा तो. ठीक आहे. So shear force at C is 7 point something ना. How much? 7.65. So 7.65. Okay. And shear force at D, maximum value here 0.64 into 10 raised to 6. Now shear force at, first we will mark E. Okay. So shear force at E is same 7.65. 7.65. At this point shear force at F is similar to this 0.55 and this is now. So from this A to B curvature is parabolic. From this B to C straight because of this B and C is in straight. So from this C to D and D to E curvature is parabolic. So curvature is parabolic. Okay, after that this is straight line and this is again parabolic. So this is the tau max at neutral axis. Here 0, here 0. So this is our A point, this is B, this is C this is D, this is E, this is F, and this is G. So this is the shear stress distribution diagram. Likewise, you have to draw shear force distribution diagram. Okay, so first you have to solve, or we have to find out moment of inertia. After that, shear stress at each and every point. And once you got shear stress values, then you have to draw the shear stress diagram. Take screenshots. Okay, so today we will stop here. In next lecture, we will solve the remaining numericals. Okay, so today we will stop here. Thank you for attending lecture. Thank you.